Hello everyone, today we are going to show you how to implement CRC by hardware. For faster performance, we prefer implement CRC by hardware rather than software. Before we start to talk about the main topic, we want to remind you that CRC is based on division. The reason is that division contains a large number of operations, so it has great ability for error detection. Among these four characters, remainder and divisor are the most important. Let's take a look at this example. Dividend is 100, 1000, and the divisor is 1011. After a few operations, note that there are not simple subtractions but XOR in the process, and finally, we'll get the remainder, which is 110. Let's focus on divisor. In previous example, the divisor bits were either 1011 or 4 zeros. The leftmost bit is not needed because the result of the operation is always 0. So now, we are going to use several registers to implement the CRC model. Let's take a closer look at the model. You will notice that if the leftmost bit is 0, the result stored in the register is assigned as a dividend, which is our augmented data word, but one bit shift to the left. This is the significant point. With this implementation method, we surely could get a remainder, but have to use 24 registers. In other words, this method is not efficient. Hence, we will introduce another method practiced by shift registers. Just like what we talked about before, if our divisor is 0, then no matter augmented data word is 0 or 1, we will still get the same bit as dividend. Let me show you another way to calculate the remainder. If you face a situation to add a 0 in quotient, then just simply put the following bit in augmented data word. Since we ignored the result from the dividend, which is 0, we can shift the augmented data word until bit 1 comes to the leftmost register. So this is the practical example to implement CRC by shift registers. Originally, the 3 registers all contains 1 0. And first, we put the first bit of augmented data word to the input. And after 2 XOR operations, we can get clock time 1 result in the register. Since the left 2most bit are zeros, we shift augmented data word until 1 is the leftmost bit. As same as the previous steps, we take another 1 to the input continuously until there's no bit left in the augmented data word. Eventually, we get the same remainder as the past method. But there are only 3 registers used in the model. This is the end of our video. Thanks for your watching.